Uh, Hello, everyone. Am I audible?
Yes, sir.
Yes,
Okay.
sir.
Okay. Good. Hope my screen is also visible.
Yes, sir.
Okay. So can anyone tell me where Rituraj stopped yesterday? Was he teaching logistic regression?
Yes, sir.
Okay. Okay. So again, I'll be continuing with logistic regression uh, and also start with an intro to classification and machine learning. To start with, what do you think? What type of learning is, classification in ML? Is it supervised or unsupervised? Can anyone tell me? And also, I would encourage you all to be a little bit more interactive. If you have any doubts, you can stop me in between, and we can clear it then and there. And yeah, so just a simple question: is it a supervised learning thing or an unsupervised learning thing? If you're talking about classification, regression, and so on.
Supervised learning, sir.
Okay. Why supervised?
So because it uses
The class
labels.
label is unknown, sir.
Okay. Yeah. Good. Good. The training data, we have a set of feature values. It can be numeric or categorical. Numeric meaning numbers like 1, 2, 3 decibels and so on. Categorical meaning you have different categories. Let's say for age, you can think uh, it can be young, old, or middle aged. If you think in terms of numerical things, it can be the actual age number. Okay. Here, the categorical output value, I mean the label, it's discrete. It's not continuous. An example for classification is, let's say you give age, gender, and income, and then we have a data set where all these features together, they'll say whether the person is going to buy a product or not. Okay, that's the label. This is one example of classification that I've given here. And as any machine learning model goes, what happens here is you have a training data set, and once you go to the testing phase, you give an unseen data as input to your model to predict the label value. Okay, that's what happens. Can anyone think of any other example of classification? Any other real life example that you can think of?
Sir, on
Any-
purchasing laptops, we bought yes or no.
Okay. Purchasing any product. Other than purchasing anything, any other things comes into mind?
Loan approval, sir.
Loan approval. That's a really good use case where again it can be age, income. whether they already have a house or not. All these things come into play, and the bank can decide whether to give uh, the loan or not. Okay, that's another example. That's good. Another recap to supervised learning. I mean, you're all maybe familiar with the supervised learning case. You have a pair of features and labels, and you learn a function f to predict y which is categorical given x. Okay, so this is classification. This is regression. Okay? Another classification example is this is a very famous data set called fashion image, where you give this image as input to your model and ask it to predict whether it's a dress, it's a sandal, if it's a trouser, shoe, bag, and so on. Okay, you have different labels. This is again a classification example that you can think of. Other examples can be credit card fraud detection. If someone else uses your credit card, the bank will call and ask just to be sure, did you do the transaction yourself or did someone else do it? And typically they look at some user information where the transaction has happened, especially if you are in an international location, they'll always call and check that you are the one using the credit card and so on. Okay. If you can think of medical diagnosis, like looking at X-rays, what can be the feature? What can be the label? Can you tell me? Like X-ray, MRI, CT scan, what can be the features? And what is your label?
Tumor, sir.
Tumor, how do you give it as input to your model? Okay, medical diagnosis, whether it's cancer or not, how will you give it as input to your model?
Sorry. Giving image to train the model.
Yeah, you can either give it as images. Additionally, you can also supply age, previous diseases or diagnosis that the patient has, and so on. Okay, that is good. What about email spam detection? Spam detection.
Sir, check spam or not spam.
Yes. Features.
Sir, features such as the mail ID.
Yeah, if you can use mail ID, or you can look at the content of the email, like look for specific words like warning, you've
Yes, sir.
been hacked or something. You can look at those things also and build your model. Okay, good. Um, but as you saw, regression, you have linear regression and so on. But since this is a classification case, there are multiple approaches that can be used for the classification problem. You have different algorithms like KNN is neighbors, logistic regression, high-base, support vector machines, networks, and so on. Okay. Okay, let me just start with logistic regression since that was going on yesterday. Okay. Again, logistic regression is used for classification and can also be used for regression. Okay. The output of logistic regression is between 0 and 1, and what it essentially does is model what I would say the probability between two classes. As I keep going on, I'll explain. Okay. But ultimately, it's linear regression with one sigmoid activation at the end. So this is what I call the sigmoid activation, essentially. Okay. This green line you see, right? That is the sigmoid activation. What does it do if the value of x, the x that you see here, if it's below 0, it will be like this. It will be less than 0.5. If it's at 0, it will be 0.5. Okay. If it's more than 0, the maximum is 1 and the values will be like this. Okay. But how do you just look at this curve? Okay. This curve. How do you use this for classification? How do you think we can use it for classification? Okay. So what you can do is you can set a cutoff that is 0.5. If the value is above 0.5, you say it's class 1. If it's below 0.5, you say it's class 0. Like class 1, class 0 meaning like if it's above point, if the value that you get is above 0.5, you say it is spam. If it's below 0.5, you set it say it's not spam. Okay. But again, it need not be 0.5. You can set any threshold, but typically it's 0.5. Okay. Uh, So this is linear logistic regression. This is what you learned in linear regression is just one more thing that you apply on top of linear regression to convert it into classification problem. Okay, that is what logistic regression is. Any doubts in logistic regression? Do you have something? Okay, no doubts.
No, sir.
Okay, then we move on to KNN instead of KNN. Okay. KNN is called K nearest neighbors. Okay, and it's also another classification algorithm that we use. The major like intuition, if you want to look at how do you build a KNN classifier is you start with a pair of data items and compute what I call the distance. Okay. An example. The features are gender, profession, age, income, and postal code. Okay. For a person. For person one, it's this one. For person two, it's this one. How do you calculate the distance between these two persons? Distance meaning not actual physical distance, how far apart they are, how similar they are to each other. Okay, the distance between person one and person one, that is zero because it's the same person. Okay, but how different is person one from person two? That's what you should calculate. Okay, uh, let's say for age. Okay, how do you calculate the distance? How do you calculate distance between age? And you can also consider income. Like, have you read about Euclidean distance or absolute I mean, distance based on the magnitude or
Yes, sir. Euclidean distance.
can you calculate the Euclidean distance between 47, 25,000? Don't take 25,000, keep plus 25. 47, 25, 43, 28. Can you calculate the Euclidean distance between these two? The output, the answer should be one single number. Can you all solve it and tell me?
Okay, sir, I will try.
Okay.
Sir, I think the answer is 5.
Yeah, it's correct. So Euclid distance, what you do is it should be 47 minus 43 whole square. That is
Yes.
4 square, 16. 25 minus 28 the whole square. That should be 9. 16 plus 9, 25.
25.
And take the square root. It's 5. Okay, good. Then, okay, and so that was the unsupervised case. KNN is a supervised algorithm. So what you also have is person 1 is a buyer, person 2 is a non-buyer. Okay. Now I have person 3. Okay. I don't know if she is going to buy a laptop or not. Okay. How can we predict this? Again, based on distance. Okay. Based on distance, if the distance is, I mean, if the person 3 is closer to person 1, then I can say that she'll also buy. If the person is closer, person 3 is closer to person 2, I'll say she won't buy. Now, again, same Euclidean distance. Tell me if person 3 is going to be a buyer or a non-buyer. Just tell me that, okay? Again, Euclidean distance between age and income only. Calculate. The idea should be calculate Euclidean distance between person 1, person 3, person 2, person 3, and tell me if she is going to be a buyer or non-buyer.
That person 2.
So person 3 is going to be a buyer or non-buyer?
It's a non-buyer.
Yeah. Okay. This is how this algorithm works. Okay. You calculate distance between the new data point and existing data points. See which one is closer and assign that label. Okay. But this is what I call the nearest neighbor. Okay. But the algorithm is named K nearest neighbor. Okay. So let's see another example. Nearest neighbor, you just take the whichever is closest and assign the table. But in the case of K nearest neighbors, okay, what you should do is sort of take the majority. Okay, let's look at this example. You have city temperatures in India and Germany. Okay, The features are longitude and latitude. Okay, some coordinates. You have Euclidean distance, and the labels are it's cold, it's cool, it's warm, or a hot. Okay, you have Chennai, Madurai, Frankfurt. These are longitude, these are latitude, and you have the labels. How do you classify Vellore? Can I again just calculate the Euclidean distance and tell me?
Sir, first calculate the Euclidean distance to each city.
Yes.
Second, identify the nearest neighbor.
Yes.
Third, label to assign, sir.
So what happened? Which label? Is it which label are you going to assign after calculating?
Yes, sir. Assign to Vellore label, sir.
Oh, that's what. Vellore only. What label I'm asking? Is it going to be cool, warm, or cold?
ఇవేగా మా చెల్లికి
Warm.
100 యాప్ట్ మామూలు యాప్ట్ కూడా కాదు.
Most likely it's going to be warm because the
నాకు తెలిసి
latitude.
చాక్లెట్ డబ్బా ఓపెన్ చేసి తినలేదేమో వాళ్ళు. ఫోటో పంపించలే, డబ్బా ఫోటో పంపించింది. చాక్లెట్ ఓపెన్ చేసిన తర్వాత పంపిస్తా అండి.
I think someone mute.
పంపించింది చాక్లెట్ కదా
Okay. And so, but in the case of
అదే
A
మనం ఇప్పటికి మా అమ్మ
needs,
10 చదివేది. ఎందుకంటే కావాలని ఉంచింది.
Mhm. I don't have the option to mute.
అభిరుచి ప్రేమికులకు ప్రేమతో మీ ప్రీతి మన ఇంట్లో లంచ్ టైం కి
Can someone mute? I don't know. I don't have the option to mute. Okay. Okay. Oops. Okay. And again, it's not that much complicated as you all saw. It's very relatively easy. The distance function need to be defined here. I've said it's Euclidean, but there are like many other distance functions also. It might not be efficient too for very large data sets, since you need to like calculate pairwise distances between any this one point and all the other points. So let's take another classification example where you have class A and class B. Okay. You have an example to classify. Some other new data point is coming here. What you do? You calculate distance between this point and every other point. In the case of nearest neighbor, you just take the nearest one, let's say this one, and say it's class B. Okay. But that might be wrong. Okay. Relying on just one single neighbor might be wrong. So what you do? You set k as 3. Okay. Set it for 3 nearest neighbors. You check 3 lower distances, like 3 distances from this point, whichever is lower compared to the others. Okay. And what you do is, okay, 2 are in class B, 1 is in class A. So I'll say this point is also in class B. Okay. Another thing you can do is set k as 5. Okay. You can take all this. Okay. If you set k as 5, majority will be the red stars. So it will be class A. That's how KNN works. Any doubts in this? You all can like have a little recap for a while, and I'll go to the next concept. Okay, this is KNN. We finished logistic regression. Then moving on to evaluation metrics. Okay. So K can be 1, K can be 2, K can be 3, K can be 5, can be 10, can be any number. Okay. How do you set K? What do you do? Anyone has any idea? How do you set K in KNN? Like number of features to select in some models. How do you do that? On what basis you do that?
Sir, as based on some metrics or parameters.
Okay, and okay, the metrics for regression it's called coefficient of determination, R square, mean squared error, mean absolute error. For classification, you have F1 score, accuracy, efficient recall, ROC, AUC, and you have many other metrics. But yes, you have a metric to measure, but on which one will you measure? You have train and test data. On which data set will you measure these metrics and make your decision? Train or test?
Sir, trains, sir.
Why train?
Sir, because the train data will evaluate the metric accurately.
But ultimately, you want good performance on test set, right?
Yes, sir.
So you have to increase test set performance, no?
For increasing the test set performance, we have to evaluate the metrics on the training data set only, sir.
Do you think that's the case? Let's say, okay, you optimize your parameters for training set alone.
Yes, sir.
You have accuracy, 100% accuracy in your train set, but your test set has 0% accuracy. Would that be fine? There was a class on overfitting, underfitting, right?
Yes, sir.
So is this overfitting, underfitting? You have 100% training accuracy, 0% test accuracy. Overfitting or underfitting?
Overfitting, sir.
It's overfitting. You don't want that, right? So instead, okay, test set is separate. What you can do is again train, you can split it as training and validation set. Okay. Then you try k is equal to 1. What's the performance and validation set? K is equal to 3. Test, you measure the performance and validation set. If k equal to 3 is higher than k equal to 1, you set k equal to 3. Okay. That's how it is. That's how you do it. Okay. For classification, you also have something called a confusion matrix. Okay. In the case of confusion matrix, what you have is like this is the actual values, the label values, positive and negative. These are predicted ones. If actual is negative, predicted is negative, then it's true negative. It's a good prediction. If actual label is positive, predicted is positive, you have true positive. That's also good. But you don't want any false negatives. Let's say the email is actually spam email, but my model is predicting it as not spam. Okay, then it's false negative. Again, same case, my email is not spam, but I'm predicting it as spam. Okay, email is not spam, but I'm predicting it as spam. But that means it's a false positive. It's called type 1 error. Okay. So you want to ideally avoid false positive and false negatives. You want to increase the number of true negatives and true positives. Then you have another metric called precision and recall. Precision, what you say is among predicted positives, how much are truly positive? Like, let's say you predict most of the email as spam, but then only some are actually spam. That means your model is predicting more false positives and your precision is low. Okay. Then recall what you see is how many positives are you actually uh, retrieving. Yeah. So that's what you check in recall. Okay. Are you retrieving more positives or not? Okay. That's another thing. Essentially, there is a trade-off between precision and recall. I won't go into the details behind that, but just the basic thing. Then you have ROC, AOC. This is the curve. Okay. You should always remember this. A random classifier. Okay. Always has ROC, AOC value as 0.5, and if the curve is going above this line, like this is better, this is better, this is better, this is better. Okay. If it goes below this line, it's worse. The model is not performing good. Okay. And if it's a very perfect classifier, it will have a point here. Okay. This is the true positive rate and false positive rate. You want your true positive rate to be higher than false positive rate. Okay. Again, you don't need to know the details behind how this metric is calculated and everything. Already Python packages can handle it for you. I'll be teaching it to the tutorial tomorrow. Okay. And this is what I was talking about. Okay. How do you select hyperparameters? Okay. It's called cross validation. Okay. This is what you've been taught till now, right? You have a data set, you split it into train set and test set. Can anyone explain me again why we need a train set, why we need a test set? Anyone?
Sir, 80% is train set and the test set is 20% means we train the model based on this data set and we test the unseen data. It classifies correct or not. Something.
Why? Okay. That is a definition that is correct, but why do we need that? It's actually, we can train on full data set and predict on full data set, no? Why are we splitting?
Sir, for example, if a product is manufactured, it work in a company, then it will go to the user how it practically implemented likewise.
So you have to look at the practical implementation. You have your own data set, you train the model, you test it on your own data set. It might be working good, but if the model is seeing something that it's never seen before, the model might be performing bad. So what you do is before itself you split. Keep this entirely hidden from the model. The model does not see this. The model only sees this. So you are sort of simulating what's happening in real life when your model is being deployed. Okay.
Yes.
And yeah, so that's the intuition behind splitting your data set. But again, splitting can be done in many different ways. Okay. This is the one simple way that you've been taught till now, like 80%, 20% or 75, 25, 90, 10, and so on, so on. Okay, one more important thing that you have to remember. When do we do 80, 20? When do we do 90, 20, 90, 10 or 70-30. When do we do that? How do you determine the percentage of train and test set?
Sir, as based on the our output in the test data set, because the output is the test data having the low accuracy compared to our trained data set, we retrain the model, sir.
No, it's not about accuracy. Like splitting itself, how do you determine the proportion of train set and test set? Okay. If your data set is very small, okay, let's say 100. If you split 80-20, you only have 20 samples in test. That might not be enough. Okay? That might not be representative of what's happening in real life. So you can do 70-30, but again, there's a trade-off. Like you will have very less to train, very so typically do 80-20 in that case. And let's say you have 10,000 data points. In that case, you can do 90-10 because even with 10%, you can have 1,000 test set data points. Okay, so it depends on the size of the data set that you have. Okay? That's how you determine the percentage of splitting. And as I said, there are many different strategies. This is one such strategy, which is called train and test. What you can do next is called cross validation. Let's say you have 100 data points. You randomly shuffle the data set. Okay, you split it into 10, 10, 10, 10, 10. Okay, what you do is take the first 9 batch, like 90, keep it for your train, keep the last 10 for your test. Okay, train the model, get the accuracy of the test set. Here, more you can call this as a validation set rather than test set. Okay? You do that. Then the next round, what you do is keep the first one as test, keep the rest of the 9 as train. And this keeps changing until you have all the batches validation or test set. Okay. This is what I call as cross validation. Why do you think this is okay? Okay. And one more thing is this is better than this one. Why do you think this is better? Why is cross validation better than simple train and test? Good.
Sir, for how to improve the accuracy on unseen data?
Yes, because you are testing all possible scenarios. You can think of it like that. Okay. You have more better estimate of your test error. I mean, that's what it is. It's called in machine learning terms, but it will basically improve the performance on unseen data. If you see that in the cross validation setting your model is performing bad, then in real life also it will be performing bad. It might be performing good in this case because that test set might be easier for the model. But here you split it test and you do the testing on different splits of the data set. So it's more, it will give you a more accurate estimate of the performance in real life. Okay? You don't need to worry about the rest. And I mean, I'll be teaching about all these in the tutorial. But there are many other cross validation methods also. In summary, what I thought today is about KNN and logistic regression. KNN is called K-nearest neighbors. You have a new data point coming in. You check the distance between the new point and all the existing points. Calculate the distance. See, take the K nearest ones, and based on majority voting, like majority class, you assign that class to the new data point that you have. In the case of regression, KNN regression, what you do is just take the average of the K nearest neighbors. Okay. Logistic regression is again classification. It's used for classification. It is actually linear. The output of linear regression passed down to a sigma function. And you set a threshold there. If it's below a threshold, you assign it as class 0. If it's above a threshold, you set it as class 1. And that's about logistic regression. And more about, we also saw what are the metrics for evaluation. We had R square and mean squared error for regression, different classification metrics like precision recall, F1 score, RCAC, accuracy is a simple thing that you all know. And we also saw how to do evaluation, like which type of split do we do. And this is the in essence, the summary of today's class. So tomorrow I'll be taking the tutorial in Python. So you all be ready with your laptops. I think you all know how to open Collab and write your Python code. Okay. I'll be going step by step tomorrow for the Python tutorial, and I think we can finish up here for today. If you have any questions, you can ask me.
Sir,
Yeah.
sir, for what purpose the evaluation metrics are used? Just finding for the distance values or for increasing the accuracies of
No, no,
models,
no.
sir?
So evaluation metrics has nothing to do with distance. It will say how good your model is. That's it. Whatever you have built, whatever model you have built, you have to check whether it's good or not. That's where evaluation metrics come into the picture. Okay. Let's say you
Okay.
tried three different models you tried. You want to know which one is best. What you typically do for classification is you calculate accuracy for three models and say whichever has higher accuracy, that's my best model. In the case of regression, it's mean squared error. All these I'll teach in the tutorial, like how to implement each of these metrics. Okay, that will be done.
Okay,
So,
sir.
distance, that's only for KN. That is a separate. Here it's about to check whether your model is good or not. That's it.
Okay, sir.
Okay. Okay then. Uh, there are no questions. We can resume tomorrow. Something is there. Like issues. Okay then. Thank you all for joining. Tomorrow we'll proceed with the Python script.
Thank you, sir.
Yeah. Thank you.